I never wanted to be an astronomer. I was always interested in physics and maths, but at university I realized I was not very good at the experiments. But I took a course in observational astronomy. And in astronomy, the experiments are already set up. They're these incredible telescopes where you just have to visit, point the telescope in one direction towards a galaxy, and you can start taking data very quickly and analyzing that data to understand the universe. So that's why we're here today, to use the Nordic Optical Telescope in La Palma in the Canary Islands to look for some of the rarest objects in the universe, gravitationally lensed quasars. My name is Cameron Lemon. I'm an astronomer at the Oskar Klein Centre at Stockholm University, and this is my 8th time at the Roque de los Muchachos Observatory, one of the best sites in the world for observing our universe.
And I'm Nikki Arendse. I'm also an astronomer at Stockholm University, and for me this is the first time observing lensed quasars.
So this is the control room, where the magic happens. We can control the telescope from here with several computers, and hopefully tonight we'll find some of these rare lensed quasars. So what is a quasar? Quasars are some of the brightest objects in the universe, but they appear as tiny dots on the sky, a lot like stars. And they're actually billions of light years away. Astronomers have worked out that they're supermassive black holes at the center of distant galaxies. And this seems like a bit of a paradox. How can a black hole be so bright? Well, in fact, there's material that's falling into the black hole. And as the material falls into the black hole, it gets so bright that it outshines all of the stars in its host galaxy. And by studying these quasars, we can understand a lot more about the galaxies they reside in, all the way up to the universe itself.
But we're not just looking for any quasars, we're looking for gravitationally lensed quasars. And this happens when, between the quasar and us, there's a massive galaxy that acts like a gravitational lens. So it bends and magnifies the light coming from the quasar, and it can create multiple images of the quasar. So that is what we're looking for, multiple copies of the same quasar. And this is extremely difficult, because this exact alignment is very rare. So it is like looking for a needle in a haystack.
The Nordic Optical Telescope is perfect for our search because of its ability to take incredibly sharp images, and its nearly 3-meter diameter mirror that can collect light from the faintest galaxies.
So now the sun is setting, it looks beautiful, and all the telescopes on the mountain are opening up, pointing towards the sky and preparing to observe. That means that it's time for us to head up to the control room and get ready for our night of observations.
What do we actually do in the control room? We have a list of targets that we suspect might be lensed quasars, but we don't know yet. So we sit here throughout the night, pointing the telescope towards each of them, and we analyze their light so that we can characterize them and decide what they actually are. We move between targets every 15 to 20 minutes, so there's not much time for rest. We drink a lot of coffee to stay awake and keep our fingers crossed for clear skies.
Is that Lyman Alpha?
Yeah, this could definitely be Lyman Alpha, yeah. It has.
So what's the second exposure? How long?
This is also 15-minute exposure. What I'm going to do...
dark now, right? So it should be better.
It should be better, yeah. We've just started the night. This could be Lyman Alpha and this could be Carbon 4. There you go. Yeah. That's 2 quasar emission lines.
We may have found something interesting. We just took this observation here of an object, and you can see that there are 2 point sources instead of 1, which may be 2 images of the same lensed quasar. But to be sure, we need to take more observations and investigate the properties of the light.
So we just got some new data for this system, and it looks really promising. As you can see on the screen, you see 2 lines. Each of these lines corresponds to one of the sources, and we've spread the light into its different wavelengths. The fact that these lines look so similar is a smoking gun signal for a lensed quasar. This similarity is much clearer in this plot, where we see the intensity of light against wavelength. Each source is represented by a different color, and the sources share the same characteristic features.
We've seen now that these 2 sources have light properties that are so similar that they have to be the same object. So they're 2 images of the same quasar that has been lensed by a foreground galaxy. So we found a gravitationally lensed quasar. Throughout the night, we continue observing and hunt for more lensed quasars.
The sun is starting to come up, so it's getting too light to take any more observations. We had a very successful night. We discovered a bunch of new gravitationally lensed quasars, and we are very ready to go to bed. Luckily, we don't have to travel far. There's accommodation for us on top of the mountain, where all the astronomers sleep during the day.
Being on the mountain is magical. On the drive up, we passed many different microclimates, landscapes and animals. And as we got higher, the misty forests opened up to reveal beautiful views and the first telescopes on the mountain. And up here, it really feels like we're on top of the world. We're above the clouds and closer to the stars than I've ever been.
Our observations were really successful. We discovered 20 new gravitationally lensed quasars. So now we know exactly where they are in the sky, and we can return to them whenever we want. Our next step is to use the data we've collected to measure the masses of the lensing galaxies, the masses of the quasars' black holes, and even measure the expansion rate of the universe. It's amazing that from here on La Palma, we are able to study supermassive black holes billions of light years away. We want to give a huge thanks to all the staff at the Nordic Optical Telescope who have helped us in this exciting step towards understanding our universe.